All right, second unit, 2.1 notes on simplifying radical expressions. Whoops, not what I meant to do, sorry. So at the top, we have a table that's already filled in for you. These are the perfect square numbers, okay? Now, these are from 1 to 15 squared, so the number times itself. These are on your desk. A more elaborate version is on your desk, but this is so you can refer to in your notes. So a root, most often we see square roots, but we can have a cube root or a fourth root and so forth, can undo an exponent. So if you were solving x squared equals 25, x would be 5, because 5 times 5 is 25. You can add this also, because the square root of 25 is 5. Okay? So this square root undoes this exponent. So when you square root the left side, it undoes the exponent, and then you take the square root of 25, which is 5. So for example, we're going to simplify these following numbers. Each should come out to be an exact value. So the square root of 36, if you look at the top, is 6. 6 times 6 is 36. Square root of 141, I think that was supposed to be 144, so let's just change that. And that would be 12. And the square root of 64, which would be 8. And the square root of 4, which would be 2. Now, if the number inside the square root is not a perfect square, like all of these were all perfect squares, then we need to turn the problem into a multiplication problem using a perfect square. So what you're trying to do is find the biggest perfect square that goes into the number we have under the radical. So for example, square root of 40. If you look at your chart, we're going to try to find the biggest number that goes into it. Now we start here because 40 would be in between those, 36 and 49. And you just divide. You can do it in your head if you know like 36 won't go into 40. 25 times 2 is 50. 16 and 16 is 32. 48, that's too big. 9 doesn't go into 40. There's our winner. It's our only choice. Sometimes more than one number will go in, and we always want to try the biggest number. So that would be the square root of 4 times the square root of 10. You could also write it like this. Doesn't matter. It's the same thing. I always write the perfect square first because that is what we're going to take out. Or this one we're going to simplify to just 2 radical 10. Don't know why I'm writing it 20. 2 radical 10. 2 times the square root of 10. And if you see, just so you know how it works, if we took the square root of 40, we get 6.32, so forth. If I take 2 times the square root of 10, I get the same answer because they are equivalent. It has just been simplified. All right, so now we're going to look for numbers that go into 54. Okay, so we go back to our chart, find where 54 would be, which would be right here in between those two numbers, and find the biggest number that goes into 54, and that would be 9. Sorry about that. Okay, this would be 9 times 6 is 54. Okay. The 9 is going to come out. The square root of 9 is 3, and the 6 stays inside. 72. This one is going to break down to the perfect square 36. That's the biggest one that goes into it. Times 2. This comes out as a 6. Now, let me talk about why I talk about going backwards. Because some of you might immediately go, oh, 9 times 8. And that is correct. 9 is a perfect square, and 9 goes into 72. This would come out as a 3. So I would have 3 radical 8. The problem is the 8 still has a 4 stuck inside. So I could rewrite this as 3, 4 times 2. And this would come out as a 2, which would give us the 6 radical 2 again. But the problem is sometimes people will just stop here and not look again. All right? That would be like reducing 25 over 50 and dividing by 5 and saying, oh, that's 5 over 10. But not going further and saying that's 1 over 2. Because we could have divided by 25 instead. The bigger number is the better one to use. All right, it's not okay for a negative to be inside the square root. Not yet. Okay? We will learn how to deal with that later in the semester, but not yet. Okay? So why does the square root of negative 25 not exist? Well, the only way to get negative 25 is negative 5 times positive 5. But a perfect square is either 5 times 5 or negative 5 times negative 5. These both equal positive 25. There is no way to get a perfect square, one positive, one negative. They have to be the same sign. So why does this one exist? Because this is saying take the opposite of whatever comes out. So the square root of 25 is 5, and we take the opposite of that. This is basically like saying negative 1 times the square root of 25. So we find the radical square root of 25 first, and then multiply by negative 1, or make it opposite. Now, I've already kind of alluded to this. When we simplify, if there's number on the outside, it gets multiplied by what comes out. I like to give a reminder to maybe do this whenever there's a number on the outside, just to remind you that this 5 has to be multiplied by whatever comes out. Okay, it's very common to forget it. So the 18 is going to break down to square root of 9 times the square root of 2. Well, the square root of 9 is 3, and the radical 2 comes along, but remember, we need to multiply these two and get 15 radical 2. Final answer. Okay, let's do some more. So this 2, got to remind myself to bring it down and multiply by whatever comes out. The 50, the biggest number going to 50 is 25 and 2. They're both radicals. The square root of 25 is 5. That's going to be multiplied. And that gives us 10 times radical 2. All right, 8, bring it on down. This breaks down to 9 times 3, but more importantly, radical 9. Don't lose those radicals. The square root of 9 simplifies to just 3. The radical 3 stays. So 8 times 3 is 24, radical 3. All right, negative 6. It's okay to have negative on the outside, remember. Negative 6 times whatever comes out. The biggest number that goes in here is 100 times 3. Don't forget the radical. That becomes 10, radical 3. These two multiply to be negative 60, radical 3. This one's a sneaky one because 64 is a perfect square. So 12 times the square root of 64 is simply 8, and 8 times 12 is 96. So always check to see first if it is a perfect square, okay? And then, reduce it. All right, when we start to introduce variables into the radicals, we can take out pairs of them, all right? To determine how many we can bring out, it depends on the index, this small little number outside. Now notice, number 5, there is no number outside because we don't write a 2. It's just understood. It's assumed to be a square root unless we put a number there, like a 3 or a 4. Okay? So, let's deal with the number first. The 32, the biggest perfect square that goes into that is 16 times 2. So, the square root of 16 is 4. I'm going to leave a space here and put the 2 here. I'm going to leave a space here also. Now, 8. I have 8 A's, which means I have 1, 2, 3, 4, 5, 6, 7, 8. Remember we talked about taking out pairs. So how many pairs are there? Well, there's exactly 4. But we could also just divide 8 by 2. So that means I'm bringing out a to the 4th. Now, until you get used to it, you can do this as a quick little way of doing this. B to the 11. It's, that's a little bit more, but just to see it for the first time, I won't do this every time. There's 2, 4, 6, 8, 10, 11. So there's 1 pair, 2 pairs, 3 pairs, 4 pairs, 5 pairs. So how many pairs came out? 5. And there's 1 single B left inside. You can put the 1 there or not, it doesn't matter. And that's our answer. 4, A to the 4th, B to the 5th, times times the square root of 2B. All right? Now, we could have just done 11 divided by 2, and that would have been 5 remainder 1. And that 1B is what goes inside. All right, simplify each into an exact value. Okay, so again, the biggest number here is 4 times 6. Square root of 4 is 2. I'm going to leave a space. 6 goes in here waiting for the letters. Now I'm just going to do the little trick here. 5 divided by 2. Well, that's 2. 2 times 2 is 4, which means 1 is left inside. Y to the 10th, 10 divided by 2 is 5. And that's it. There's nothing else left inside. When we're doing square roots, it's pretty easy. It's either going to be even or odd. And if there's odd, 1 is going to be stuck underneath the radical. Okay? 128. 128, the number first. 64 times 2. This is a perfect square. 2 is not. The square root of 64 is 8. The square root of 2 goes here. Now we divide. 9 divided by 2 is 4. That leaves 1 inside. Y to 14. 14 divided by 2 is 7. Z3. 3 divided by 2 is 1, and that leaves 1 inside. Again, remember, slow down, rewind if you have to, whatever you need. And if you have questions, make note of them on your notes and ask in class. All right, 98. What number goes into 98 that's a perfect square? Well, that's the number 49 and 2. So the square root of 49 is 7 on the outside. Leave a space. Put a 2 here. A, 2 divided by 2 is simply 1. B, there is not enough. There are not enough B's in there. There's only 1. We need at least 2. So that's stuck inside. And then C, 14 divided by 2 is 7. And that's it. Now, just like we said before, okay, if there's a coefficient outside, we're going to multiply. But if there's letters outside, we add the exponents. So remember, this x here is a 1. So let's do it. So again, you might want to bring this down and remind yourself that there's a 6, and there's an x, and there's a y squared. We'll be changing these possibly. Okay, so 12 breaks down to 4 times 3. So the square root of 4 is 2. The square root of 3 goes right there. Now x's. 6 divided by 2 is 3. Now there's 2 ways to do this. You know it's 1. Okay, you're bringing 3 out. You could change that to a 4 right there. Or if you need to be more concrete and write the x to the 3 there and simplify on the next line, that's fine also. You do what works for you. You can change it to 4 right away, or do this. Now y to the 3rd. 3 divided by 2 is 1, and 1y stuck inside. We have to clean it up anyway with the numbers, so this method works fine. 6 times 2 is 12. X to the 1 times x to the 3, add them, x to the 4. And y to the 2 times y to the 1, add them, y to the 3. And there's my final answer. 12, x to the 4th, y to the 3. Okay, a couple more. Remember, and even if you don't want to write them, you can just do an arrow to remind yourself. So 18 is 9 times 2. Keep them under radicals. So here's the 5 times the square root of 9. And the 2 is going to go over here. Sorry, my bad. The 2 goes under the radical. And then the x's, I have 5 divided by 2. So I already had x squared. I'm going to show the other way now. X squared. Now on the inside I have x to the 5. So 5 divided by 2 is 2, leaving 1 behind. So I had 2. I'm adding 2. So I'm doing it here 4. Again, you can do like above where you write them out and add them later. If you can compile them right here, go for it. Whatever's best for you. 9 for the y divided by 2. Okay. So I have y to the 3 out here. 9 divided by 2 is 4. Okay, which leaves 1 inside. So then I erase the 3, add 4 to it, and get 7. And all I have to do is clean this up. 15, x to the 4th, y to the 7, times the square root of 2xy. And one last one. Don't forget the negative. Notice the 16 is a perfect square, so that's just 4 right there. Then I have an x to the 1. X to the 12, 12 divided by 2 is 6, but I already had 1 out here, so 1 plus 6 is 7. My y's are odd, so I'm definitely going to have something left over, 1 left over, and 7 divided by 2 is 3. I didn't have any y's on the outside, so it's just 3. And that's it for lesson 1.